This video is a demonstration of the station demand forecasting tool that has been developed by the Transportation Research Group at the University of Southampton. It's currently hosted on DAFNI, which is the Data and Analytics Facility for National Infrastructure, and the DAFNI team created this web interface and also the job management and visualization features that you'll see later on. You can find more details about the underlying model and the situations that it's suitable for in the links that accompany the video. A model run can consist of any number of potential new stations, and in the setup page you can say whether these should be treated in isolation, so they are considered potential alternative locations, or whether they should be treated concurrently, so there you assume that they all coexist in the new situation, for example in the case of a new line. Also in the setup, you can adjust the service frequency of existing stations. You might need to do this if the proposed scheme would result in additional services calling at an existing station. In the Add Stations page, you can specify one or more stations for a model run. You provide an ID and a name of the station, and also the region that it's located in. To obtain the coordinates of the station, you can use the built-in interactive map. Now each station has two locations. The first is the actual physical station location, and the second is the expected access point to the station from the existing road network. So you move the markers on the map to indicate these two locations, and the coordinates are then automatically brought into the setup page. You then carry on to set the other variables that are required by the model, and when you're finished you add the station, and you continue adding new stations as required, and you can delete stations at this point as well if you need to. The next step is to configure exogenous data for the model. The model uses resident population and workplace population from the 2011 census. If there's been significant new housing built since then, or additional sources of employment, or if there's expected to be new population or new employment in the future within the planning horizon of the scheme, then you can specify that information on this page. Additional population or houses need to be associated with an existing postcode. And you can use the interactive map to locate a suitable postcode for each new housing development. So you go to the map, click to show the postcodes, and you can then zoom in and locate a particular postcode where you want to assign new houses or population to. Just copy the postcode and then go back to the exogenous data page. And you just fill in the details and click Add. Similarly, for workplace population, you can add the workplace zones to the map, select a suitable one, copy its code name, then go back to the exogenous data screen and add the details. So you can continue to do that and build up as many additional jobs houses, or population data as you need. Having configured the proposed new stations and supplied additional exogenous data, you can now proceed to the job submission page. You start by giving the job a name, and then choose the number of processor cores to assign to the job. Currently there's a maximum of 30 available. You should then run the pre-flight checks to make sure that the data you've entered is all valid. On this page you can also download the configuration file in JSON format. This will be useful, for example, if you want to rerun the model later with small configuration changes. So on this page you can also upload an existing configuration file. This will replace any information provided on the previous pages. This allows the information for the model to be generated from other information systems. So when you're ready, you then click the Submit Job button. You can monitor the progress of submitted jobs on the Jobs page. You can see that the job we just submitted is currently processing and the date and time that it was submitted. After about 20 minutes, this particular job is completed and the status changes to processed and the date and time of completion is shown. To view information about this job on subsequent pages, we now need to tick the checkbox next to it. At this point we can check the log files for the job to make sure there aren't any issues we need to be aware of. We select the name of the job and then click the Get Logging Info button. The log messages are grouped into warnings, errors and information. In this case we've just got information messages and can see the progress of the job. For this job we can see that choice sets were generated for around 100,000 postcodes. These choice sets are used in the station choice model to determine the probability of a station being chosen by someone beginning a journey from each postcode. We can now move on to see the results of the model run by going to the visualization page. We select the name of the job and then click the Get Results button. In this example, the forecast is for between 420,000 and 480,000 entries and exits per year. As the underlying model was calibrated using 2011 data, an uplift is applied that represents the change in entries and exits at the calibration stations in the relevant region since 2011. We can also download the results as a CSV file. Also available on the visualization page is a choropleth map that shows the probability-based catchment for the proposed station. This is at a high spatial resolution and shows the probability of the proposed station being chosen for each postcode, with the darker colours showing a higher probability. It's important to note that this catchment map only indicates the probability of someone choosing to use the proposed station if they decided to travel by rail. It doesn't indicate the likelihood of rail being chosen as the mode for trips from each postcode. The model is also able to estimate the abstraction of trips from existing stations. In this example, we are looking at abstraction from Rhiwabon and Chirk stations in Wales if a new station, known as South Wrexham, was opened. In this case, the results show that there will be a 40% reduction in entries and exits at Rhiwabon station. This is important information for any analysis of the costs and benefits of a new station, as otherwise the forecast trips for a proposed station might be considered all new trips, while this analysis shows that a large proportion are simply existing trips switching to the proposed station. We can visualize how the catchment for an existing station changes. This is the catchment of the proposed new station. And this is the catchment for Ruabon before the proposed new station. And finally, this is the catchment after. As you can see, there has been a reduction in the probability of Ruabon station being chosen for many of the postcodes to the west of the station. That's the end of this video demonstrating the automated station demand forecasting tool. For more information about the model underpinning this tool and how it was developed, please follow the links provided with this video.